Okay, so let's go do some homework-like problems using the cofunction identity idea. So the first set is to basically rewrite a function in terms of its cofunction identity. So remember, we have three sets of cofunction identities, right? Sine and cosine are cofunctional, cosecant and secant are cofunctional, and tangent and cotangent are cofunctional. So three sets. So the sine of 32, right? How do I rewrite that? Well, first of all, I need the cosine. Right, cosine, and again, I think we're talking equality here, right? So sine of 32 is equal to what? Well, it'll be equal to cosine, and this is where we'll pull out the fact that we're talking complements. So basically, we're talking 90 minus 32, right? And so doing that, doing some borrowing, right? I think we get 58. So the correct way to do that, right, is the sine of 32 is the same thing as the cosine of 58. Again, I'm using the cofunction identities. We know sine and cosine are equal, right, if we're considering their complementary angles. So I have 32, its complement is 58, so sine of 32 should be the cosine of 58. All right, and then there you have it. Secant of 25, well, again, secant in terms of its cofunction would be cosecant. So again, doing the math, we just need to subtract 25 from 90. So doing a little bit of math here, we get 6, so 65. So secant of 25 would be the same value as the cosecant of 65, right? And again, because we found earlier that cosecant and secant are equal to each other as long as the angles involved are complements. Okay, the next one's a little tougher because we actually don't have an angle, right? So maybe this is where we kind of use this or whatever the case might be. So we know by definition, right, whatever this thing is here, let's just call it, this is the theta that we have. This has to be complement. So maybe it's as simple as just taking 90 and subtracting theta plus 10, right? That's what we did here, and that's what we did here. So I'm just going to do the same thing there. Doing the math, we get 90 minus theta minus 10, and it looks like we get 80 minus theta, and that's degrees. So tangent, right, is cofunctional to cotangent, and if cotangent of theta plus 10 would be the same thing as 80 degrees minus theta. All right, and I think it's pretty easy to see that if you add these up, the thetas will go away, and 10 plus 80 is equal to 90. So they are, in fact, complementary like they should. All right, so don't let the variables throw you off. We're still subtracting something from 90 to build the cofunction identity. You even see it happening, right, in the way it's officially written. Alrighty, so the next gambit, we actually have to find an angle theta that satisfies the situations below. All right, and the first thing we notice, we're talking about things being equal. All right, and this opens up a whole Pandora's box of things. We'll actually take a close look at it in some situations, but for now, let's use the fact, what do we know about sine and cosine? We know that they are cofunctional. This equality is true as long as this angle here and this angle here, right, add up to 90 degrees. So they're complements. So to figure out what our theta is, I'll just take the theta for the sine, add it to the theta for the cosine, and together they should equal 90 degrees, being cofunctional angles. That's what's supposed to happen. So we basically get 3 theta minus 30 degrees equals 90. If we add 30 degrees to both sides, this is 3 theta equals to, what is that, 120? And then dividing by 3, and we get theta equals 40 degrees. All right, and so there's your angle theta. And again, if you did it real quick, 40, 2 times 40 is 80, minus 30, right, would give us 50. So we can still see that they are, in fact, complements. 40 and 50 equals 90. Again, we're saying we're equal, but I notice I have a cosecant is equal to a secant. So what can I take advantage of? They're cofunctional, right? That in order for this equality to happen, this angle here and this angle here have to equal 90 degrees, right? Because the only way this equality happens for secant and cosecant is if the angles involved are complements. So again, you see we're basically solving a linear equation. So if I combine like terms, I think we get 4 theta plus 30, I believe that is, equals 90. And then subtracting 30 from both sides, we get that 4 theta equals 60. Divide by 4, and I think we find that theta equals 15. 15 plus 10 equals 25. 30 plus 15 is 45, and 20 gives us 65. So there's your check, and we can see they are in fact complements, which they should be. That's the only way this can happen. Last but not least, we have a cotangent of function value of cotangent equal to another function value of tangent. So how does this equality happen? Well, it only happens if they're complementary to each other. So theta over 2 plus theta minus 9 has to equal 90 degrees. What I like to do, how about I write it this, theta plus theta minus 9 equals 90. I actually like to just get rid of the fractions. So there's a lot of ways you can do this. This will give me theta plus 2 theta minus 18 equals 180. Alright, this is 3 theta minus 18 equals 180. Add 18 to both sides. We get 3 theta equals, I think that's going to be 198, if I'm not mistaken. Okay, divide both sides by 3. And I think we end up, that's 6 times, remember, that's 66. So we end up with 66. So this ends up being 33. And I think this would end up having to be 90 minus 33, 53. That would have to be 53, which is true, right? Because 66 minus 9, right? Wait, let me make sure I got that right. 7. 60, it would be 57. So 66 minus 9 is 57. So it all works out in the end. So there's your homework-like problems. Again, we're talking about equality, and everything hinges on, all these equalities are kind of limited to the fact that we have to have complementary angles. So kind of a hard identity to use. It does come up from time again to use for us. Sometimes it's convenient to write something in terms of sine, something in terms of cosecant, or whatever the case might be. But we'll probably end up using different identities, as you will see. But there's where we're at in our discussion. So that wraps up 2.1. Hopefully you guys have learned a lot. We've got a new definition, which creates new things to do, new channels of learning. So if you have questions, please ask them on Canvas at request a virtual office hour. All right, you guys get on to your homework and get to that Canvas quiz, and let's keep on motoring ahead, learning more and more trig as we go along. Thank you for your time and effort.